This video is about parallel lines, perpendicular lines, and also how to find the midpoints, that is the halfway point along a line between 2 points that you know. So first of all, let's look at midpoints, which are surprisingly easy. All you have to do is find the average of the two x coordinates of the 2 points, and then find the average of the two y values. So you add the two x values together and divide by 2 to get the average. You add the two y values together and find the average by dividing by 2, and bingo, you've got yourself a midpoint. So here's an example down the bottom. The two x values are -4 in the first point and 2 in the second one. Add them together, divide by 2, and we get -1. The y values, 3 and 7, add to 10, divide that by 2, and we get 5. And now we know that the middle of the line joining the points -4, 3 and 2, 7 is the point 1, 5. Parallel lines have got a gradient that has to be exactly the same as the gradient of the line you're interested in. Perpendicular lines you can find by flipping them upside down, so put your denominator on the numerator on the denominator, and then changing the sign. If it's positive, change it to negative. If it's negative, change it to positive. You can write it as m1 equals -1 over m2. So parallel we represent with those two lines with arrows on them running in the same direction. Perpendicular means a right angle. So the lines meet at a right angle. And here's some examples. So if your first gradient was 2 and your second line had a gradient of 2 as well, they would be parallel. If the first one had a gradient of -1/2 and the second one had a gradient of -1/2, parallel. If the first one had a gradient of 3 and the other one had a gradient of 1/3, it wouldn't be either. But if it was -1/3, then you could say they're perpendicular. So in the second one, in the second last one there, 3 and -1/3, they are perpendicular. And likewise, 2/5, turn it upside down and change its sign, you get -5/2. So that's all there is to parallel and perpendicular lines. So let's have a look at these things in action. Here's a question with 4 parts to it. The first one is to find an equation that joins 2 points. We've done that before. The second one is to find the midpoint of that line. That's going to use that average of x values, average of y values. Then we need to find the equation of the perpendicular bisector. Well, we've had a look before at finding equations, but we're going to have to use perpendicular gradients in there. And the last one is to find a parallel line that passes through a given point. So let's have a look at the first part, finding the equation joining the points. We've done this before, and the two equations that we use are there in those red boxes. So first of all, we have to figure out the gradient between those 2 points. y2 minus y1 over x2 minus x1 figures out that the gradient has to be 2. Straight away I know any parallel line would also have to have a gradient of 2. Any perpendicular line would have to have a gradient of -1/2. But we'll get to that later. Alright, to find the equation, I use my y minus y1 equals m times x minus x1. I throw in my values for x1 and y1 and my gradient of 2, and then I expand the bracket, add 2 to both sides. I get my equation y equals 2x minus 8. That's the equation of the line joining the point 5, 2 and 9, 10. So next up is the midpoint of the line. So this is where I take the average of the two x values. 9 plus 5 is 14, divided by 2 is 7. The average of the two y values, 10 plus 2 is 12, divided by 2 is 6. I get my point 7, 6. That's the middle of that line joining 5, 2 and 9, 10. Now I'm going to find the perpendicular bisector. So a perpendicular bisector means to cut in half, so it goes through the midpoint. And perpendicular, don't forget that's using this rule, that a perpendicular line has a negative inverse gradient. So I have to take my gradient of 2, flip it upside down to get a half, and change its sign. From positive it changes into negative. So negative a half is the gradient I'm going to be looking for. So that's really all the hard work there is to it. Now I'm just basically finding an equation of a line with a given gradient of negative a half and passing through a known point of 7, 6, just like I've done before. So I use my rule y minus y1 equals m times x minus x1. I put those values in, the x1, y1 values and the gradient of negative a half, and I do my algebra, figuring out that the gradient, that the equation is y equals a half x plus 9.5. Now to figure out the parallel line, we're talking about the parallel line that passes through the point 5,7. So once again, I've got a gradient for parallel, it's the same, so it's 2. I've got a point 5,7, and I just put it into my rule of y minus y1 equals m times x minus x1. And I do my algebra to figure out that the equation of the parallel line is y equals 2x minus 3.